Okay, so yeah, let's do C here. So 1C, so number 1, part C. This is homework number 10. And GCD 8, 88, 64. So GCD 8, 88, 64. So number 1 says by the intersection of sets method. So remember on the exam, I aim to not surprise you. That's my teaching philosophy. No surprises. I want you to know exactly what I'm expecting for the exam a week from today. That is that you can actually show me the different methods. So this one would be intersection of sets. So there'll be one of them where you got to do the intersection of sets, another one where you got to do the prime breakdown, which we did that. We'll do that again today. And there's going to be another one we'll do today called Euclidean Algorithm Method. So all right, so let's try this out. So GCD first off. So what does it mean, intersection of sets? What do? You got to grab each of the, we always start with prime breakdown, huh? We always start with prime breakdown. So let's take that 8 and, yeah, let's do it right here. Break it down, 2 times 4, 2 times 2. So 8 is 2 to the third, right? Can you do the other 2? So take the 88 and break it down. Take the 64 and break it down. Break them all the way down to primes. And then we'll start thinking about all the things that go into them, right? Give you a second to do for sure on the exam. 8, whoops, got the wrong color there. So 8 times 11, 2 times 4, 2 times 2. So what's that? 2 cubed times 11? 2 cubed times 11, right? For the breakdown for that. And then 64 is 8 times 8, 2 times 4, 2 times 4, and each of those 4s is 2 times, hopefully I'm not being too scribbly here, I'm trying to go quick. So how many 2's we got there altogether? Yeah, 2 to the 6th. So 2 to the third, 2 to the third times 11, and 2 to the 6th. So that's we always start with that, don't we, for all these methods. Because you might feel like, wait a minute, you're doing the prime factorization method. Well, actually, both these methods start with the primes. So they both start out this way. And now I've got to take that and I've got to do like the table things. Remember those? You've got to come down here and do the table. You start with 1, Remember the table stuff? You've got to find all the numbers that divide into 8. So how do you do it? You put one of the primes, bless you, one of the primes in each direction, don't you? One of the primes across the top, one of the primes down the side. You just keep multiplying by that prime every time until you get up to the maximum. We've only got 1 prime. For 8, it's just 2 to the third. So you just go times 2, times 2, times 2. There's 2 to the third, huh? So that's all we're going to do. And then that's just all times 1, so that's just 1, 2, 4, 8. Good for the first one? Remember how that works? So maybe it'll make more sense with the 88, the one in the middle, the black one there. So for the one in the middle, I'll have you start with 1, and then you put one of the primes across the top. That'd be the 11. And then the other one, you go down. Times 2, times 2, times 2. And then you just multiply all the rows and columns together. Is this making sense? So for the 8, we just had a single prime. 8 is made out of 1 prime number, right? 2 to the third. So you always start with a 1 and a 1. It always starts with a 1 and a 1. And then you just multiply one of the primes down, the other prime across, until you get to the maximum. Meaning 2 to the third, that's 8. That's the maximum. Same thing here. 2 to the third and 11, that's the other prime. And just 1, 11. All right, so then you just multiply them all together. 1, 11, 2, 22. See, I'm just multiplying. 4 times 1 is 4. 4 times 11 is 44. 8 times 1 is 8. 8 times 11 is 8. All of those numbers are numbers that go into 88. In fact, that's all the numbers that go into 88, isn't it? That's all his divisors, all his factors. Remember this? We did this in last night's homework, or what the homework you just turned in. Okay, now this one, start with 1 for the blue one, 64. We've only got 1 prime. What? 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So it's just going to be those same numbers because they're all just multiplied by 1, huh? So there's all the numbers that go into 64. That's every divisor, every factor of 64. All the numbers that go in. So I'm doing the GCD, GCF, same thing, by the intersection of sets. So I've got to show all the numbers that divide into them. I've got to find them all. Those are all their divisors, right? We're trying to find the greatest divisor they have in common. That's what GCD stands for, right? Find the greatest divisor they have in common. So can you just look at those boxes now and tell me what divisors? Well, maybe better if I reorganized it. I don't know. Whatever. You don't have to. It doesn't matter to me. Whatever works for you. Maybe I'll rewrite it over here. So the 8, what was his thing? 1, 2, 4, 8? Okay. So 1, 2, 4, 8. That was his divisors. The block with the 88 was all those numbers. So, right. Is that going to be 1, 2, 4, 8? So for the 88, it was, you can put them in any order. 1, 2, 4, 8, 11, 22, 44, 11, 22, 44, 88. And then the blue one, yeah, just keep doubling all the way. Okay, so 64, 1, 2, 4, 8, 16, 32, 64. Okay, so what is their the greatest common divisor? Those are all their divisors, right? These are all divisors. These are all the numbers that go into those numbers. What divisors do they have in common? Well, these ones, huh? Those are the only divisors they all three have. Right? Those are the common. So what's the greatest among the common divisors? 8. See, that shows intersection of sets. See what I mean? We're showing the sets, a set is just a collection. So we're showing the collections of divisors, and this is the intersection, right? This is the greatest among the intersection, what they overlap, what they have in common. Make sense on that? The GCD is 8. So that's about as hard as that one gets. We good there? Questions I can answer on that? We'll try 2. You tracking with me? So I found so I'm down here. I'm doing LCM down here. So now I'm going to do the 88. This is part B. We finished the GCD. That was 8. Now I'm going to go 88 times 1. Oh, that's big already. 88 times 2. Already in trouble. 160 and 60. 196, I think. Times 2. That's about as far as I want to go. So, okay, now I'm looking. Let me add some more to this list. Times 9, 72. Times 10, 80. Times 11, 88. There I got a match. Okay, let me do the bottom list now. 64 times 1 is just 64. Times 2 is 128. Times 2, I think it's 5. Times 3. No, I don't know what it is. Times 3 is 180 and 12 and 192. Times 4, is it 256? 256. Times 5, 300 and choose calculator, 320. Times 6, something big, 360 and 24, 384, I think. Anyway, on and on it goes. Man, so we're looking for something that's in all 3 lists. I don't see anything right now. I'm going to have to go further. This is not easy. All right, I'm going to go back. I'm going to have to just keep making these lists bigger. So I'm going to go back to the 88. Times 3, what's that? 240 and 24, is it 264? Thank you. Times 4, 320 and 352? Is that right, I think? 88 times 4? Yeah. Okay. And 88 times 5 is 440, huh? Do you see any overlap between the bottom 2 lists? Where? I don't see anything. The bottom 2? The black and the blue? I don't see anything match yet, do you?
No. It doesn't match till 704.
704, okay. Wow, these are painful. I thought this would be easier. Times 7, what's the next one? Tell me after 440. What you got?
528.
528? What comes next?
616.
616. And then 700 something, huh? 704. Carissa, thank you. All right, now the bottom, the blue, We got to keep going on the blue up the line. Just keep, you can just keep multiplying by 64. So what comes next? 448, and then 512, 576, 6, 40, 704. Okay, so 704, and now I assume that's somewhere in the 8 list. What's that? Yeah, I'm at 88 right now. I got to keep going. Oh, times 88? Oh, I don't want to go there. Yeah, so you wouldn't have to list all of these. You just go ... dot, 704, which is 8 times 88. It is. Wow, you would have had to list 88 of those. This is a terrible method. This is terrible, isn't it? Yeah, this is a method that's mainly meant to give you the feel of what's happening, but it's not a good way to solve problems, is it? It's a lousy way to get answers, but it shows you what's really happening as far as, we have that in math. We have back and forth. Things that are more like models, they show the reality, they model the reality of what's happening, versus algorithms, which crank out answers quick and fast, right? So this method is to show kids, hey, what is an LCM? Well, if you listed all the multiples, it's the lowest one they have in common. So by listing all these multiples, 704, 704, 704 is the lowest one that appears in all 3 lists. 704. That's terrible. So that's the LCM. There'll be like 7 of those on the exam. I'm just kidding. All right, it won't be that bad. That's the worst of them. Okay, we good with that? So that's intersection sets for GCD and LCM. That'll be on the YouTube. If that was too fast and confusing, it certainly was messy. All right, so let's go on now to 2C, which is 96, 1764. So they want GCD, 96, 1764, and what is it? 630. Trying to do the worst of your homework here. So they want GCD. Now we're doing the prime factors method. This is way better. This is a way better way. There's actually even a better way. But this is quite a bit improved for forgiveness. So you start the same. You got to break them down to primes, right? All these methods start with that. Well, not all, but these two do. So take the 96 and break it on down. Use your calculator. Find out what the guts of a 96 are. And then take 1764. Break it on down. Find the guts of it. And then take 630 and break it on down. You guys do this you take biology and cut things apart and find out what's inside of them? My daughter was sharing with me last night at the kitchen table that she sliced into a squid in biology class yesterday. Her first dissection. She was like, it was totally cool. To put your finger in the little holes where it blows the air in, the water in and out. Anyway, she had pictures. It looked pretty cool. All right, so break apart these numbers. So the 96, break it apart. What goes in there? Just use calculator. 2. I don't know. When I look at 96, I don't know everything in the world. I just know 2 goes in, because it ends even. So I just start simple. Just take your calculator, go divide by 2, be 48. And then that one I recognize. 6 times 8, 2, 3, 2, 4. 4 is 2, 2. So be careful. It's easy to lose one. If you drop just one number, it'll really mess you up, Got to be really careful, especially the number way up here. Any number that was at the end of a tree, call that like a leaf. Sometimes people say that. The leaves, all the ends of the trees there, those are the pieces, right? So how many 2s we got there? Looks like 2 to the 5th, 5 of them, times the 3. And if it was my test, I was taking a test, have my calculator with me, I would double check it real quick to make sure I didn't mess anything up. I would go 2 times 2 times 2, 5 times 3 equals, and it better be 96. And then I know I've got the guts of a 96. I've sliced open the 96. Those are the primes inside of the 96. So let's take apart the 1764. I certainly don't know 1764, but I know 2 goes in because it ends even. How many times? Hold on, I don't know. 800, 850, and 32. 882, is that right? Then that is 441. That, I know 3 goes into that, or 9 does, because you add up the digits, it's divisible by 9. 441, if you add them up, that's 9, so that means 9 goes. Remember that trick works for 3 or 9? So I know 3 and 9 go into that number. I don't know how many times. Somebody have it? 49. Oh, and there's a number I recognize. 7 times 7, 3 times 3. You see that? There's all different ways. Doesn't matter how you do it. There's all different ways. You'll get the same stuff, unless you don't mess up. So what do we got? Don't forget anything. 2 2s, 2 3s, 2 7s. 2 2s, 2 3s, 2 7s. I would double check that if my test was on the line. 2 times 2, times 3 times 3, times 7 times 7. It better be 1764. It's the guts of a 1764. Finally, the 630. Anytime they end in a 0, I just peel off a 10. And then that's 7 times 9, 2 times 5, 3 times 3. And what is that? So we got a couple 3s, a 2, a 5, and a 7. So a single 2, 3 squared times 5 times 7, right? There's the prime. I would double check if it was a test. So we good there. Let me squeeze that in a little bit better. Let me move this over. Slide this down. 2, 3 squared times 5 times 7. Okay. Okay, so now let's put them together on a fresh screen and do the GCD, and we'll do the LCM. Just as easy, snap, snap, we'll be done. Way better than the other method. So, all right, so I'm going to copy them over to a fresh screen. So we have the 96, which came out to be 2 to the 5th times 3. So remember, this is where you line them up, and every prime has his own column. Next comes the blue 1764. 1764, which broke down to be 2 squared, 3 squared, 7 squared. So 2 squared, 3 squared. And I'm going to move the 7 squared over there. Why? Because I know I have a 5 coming in the next one. And I want to keep things lined up. So over here, 2, that's 630. Which is 2, 3 squared, 5, 7. 2, 3 squared, 5, 7. All right. Are you ready? GCD. So let me see what you remember. Let me give you a second. Okay, so how do we do it? What do you do for GCD with this method? Least, yeah, I tried to key your memory by, it's like the opposite of the word. Greatest, you actually take the lowest of everything. Why? Because that's what's happening. Remember I did the me and Jose, what we have in common thing? I said if Jose had 2 quarters, I had 3. What do we have in common? What's the greatest amount we have in common? 2. We both have 2, right? So it's the lower of the 2 numbers is the greatest amount in common, isn't it? So when it comes to 2s, what's the greatest amount they have in common? Whichever's lowest. It should be this guy, 2 to the 1, or just a regular 2, however you want to write that. Just a single 2, right? That makes sense so far. No, if I said that, hey, how many 2s do you guys have in common? 1, 2, right? They all have 1, 2. They don't all have 2 2s. So the greatest amount they all have is 1, 2, isn't it? How about 3s? What's the greatest amount you guys have in common? A single 3. How about 5s? What's the greatest amount you have in common? They don't have any in common. It's none, in other words. 7s, the top one has none, so none. 2 times 3, 6. That's it. That's the GCD. That's so much easier than intersection of sets. And LCM is crazy easier. Let's do LCM now. Is that okay so far, though? Is that making sense, what I did there? I just took the lowest power on 2, the lowest power on 3, the lowest power on 5, which is no 5s, and the lowest power on 7, which is no 7s. It's just lowest, lowest, lowest. Lowest. All the way across, right? Greatest amount in common actually means lowest amount that anybody has, because that's the greatest amount they have in common. So next, LCM. Now, what do you do for LCM? It's just the opposite, huh? These guys are just the opposite. So for the word in the front is least. Remember, it's actually highest or most or biggest. It's the opposite of what you would naturally think, right? Because you're finding a bigger container that they fit into. So if I said, Jose's got 3/4, I got 2 in my pocket, what size container can hold his or mine? 3/4 container. Can hold his or it can hold mine. Not together, not at the same time. It's one or the other, right? That's what a multiple is. It can't fit all of them at the same time, but it's just one at a time can all fit in there. What's the least container that can hold his or mine? That's the idea with least common multiple. So, in other words, it's the bigger one, right? It's, for Jose, it'd be Jose's number of quarters, 3. It's the bigger number. Is the smallest container that'll hold either one. So what's the biggest power on the 5? On the 2, it's 5. 2 to the 5th. What's the biggest power on the 3? 3 squared. What's the biggest power on the 5s? Just a single 5. Biggest power in the 7s? 7 squared. So whatever that is, I have no idea. Somebody got it? Anybody? 17,000? 70,560? Wow, that's big. Anybody else getting that same thing? Nobody else getting that same thing? Yep. Agreement? All right. Good. I would do it in my head, but I hate to show off, so I just let you guys do the calculator. I'm kidding. I can't do that in my head. You know who the fastest human real quick, enough of that. So, I'm not him. I need the calculator. 70,560. So we good on these two methods? To make sense. I'm going to go to something new now. So we've got the intersection of sets. So I'm going to ask you for one of each on the exam next Wednesday. I'm going to say, give me, here's some numbers. Give me intersection of sets method. I'll probably ask you, it can't be too long to do everything. I'll probably ask you for like GCD for one kind and LCM for the other. In fact, I remember that's what I made a test. So anyway, you have to do one of each, basically. So I hope that's good for you. Glad to help you. My office hours are next Monday if you want to talk more about that. I'll show you probably on practice exam day, but you don't need it for now. You can get answers without it. All right, so product two numbers, 13, 13, GCD, okay. On number 4, they're hitting on a special thing. It's saying the product of two numbers is 13, 13. 13, 13, GCD is 13, find their LCM. So GCD 13, find LCM. Find LCM. Okay, product two number 13. Right, now, so what do they even, where did this come from? What are they talking about? What you need to know is a certain theorem or formula or whatever. Here it is. I'm going to want to put this on you get a 3x5 card, right, for the exam. Put anything you want on the front and the back of a 3x5 card you can have with you during the exam. Anything you want. Here's something I would for sure put on there. GCD, or if you have two numbers. Product, you know what product means? Multiply. Product means multiply. So they're saying the multiplying of two numbers. So first number, let's just call it that. First number times second number equals the GCD of those numbers times the LCM. I'm going to give you that like magic. I'm not really giving you a reason why that's true. I just don't have time. So maybe later, probably not. Won't have time to prove it. I don't even know how to prove it off the top of my head. But anyway, it's true. So you want to have that on your 3x5 card. There will be one question. I think I put 1 using this principle. So that means if you have any two numbers, if you times them, it's going to equal whatever their GCD is times their LCM. Okay, so what? Well, what that means is on this problem, they're telling me that the product of two numbers is 13, 13. They're telling me this whole side here came out to be 13, 13. I don't even know what the numbers are, but they're telling me what they multiplied to be. They're saying, hey, we multiplied these two numbers, boom, and the product came out to be 13, 13. So that's the left side of the equation. And then on the right side, they're telling me the GCD is 13. The GCD is 13. Over here's the LCM. They're saying find the LCM. It's like solving an equation for x. Do you remember that from algebra? So pretend this is like a big X over here. That's what we want to find, right? That's our variable. How do you solve for x there? How do you solve for the LCM? Yeah, you just divide. Let me use a different color there. Just divide by the 13. Exactly. Everybody good with that? Remember, whenever you have something multiplied, you get it along by like. So just divide by 13 on both sides. Boom, boom. Hit the buttons on your calculator. I have no idea what that is. Anybody got it? 13 divided by 13? Oh, it's 101. Yeah, because 100. And yeah, anyway. 101. There it is. That's what there was. So if we know what two numbers multiply to be, and we know one of their GCDs, we can find their LCM. That's what that means. Because two numbers multiplied will always equal their GCD times their LCM. So this you want on your 3x5 card. I think there's another GCD of two numbers is 13. Their LCM is 390. One of the numbers is 78. LCM, GCD. Find the other number. You can see it goes off the screen, but that's all we need. So write that same formula, which means first number times second number is GCD times LCM, right? So write that same formula and then plug in what you can. You should have one thing left that you don't know that you can solve. So the GCD is 13, so that goes right here. The LCM is 390, that goes right there. One of the numbers is 78. It doesn't matter whether you call that first number, second number, whatever. It doesn't matter at all. I'll just stick it here. The other number, call it X or whatever. Call it whatever you want. Call it Joe. It's just a name. It doesn't matter. So you're trying to solve that little equation for X for the other number. So what do you do to solve that equation? Just divide again, huh? Did y'all see that? We're just going to divide you always divide by whatever's next to the X or the thing you're trying to get alone. Let me look back here for a minute. So on this one, you see I divided by the 13 because the 13 was next to the letters I wanted to get alone. Right? You always divide by whatever's next to your X or your whatever, your variable. So in this case, I'm going to divide by what? The 78, huh? Because that'll get the X alone, won't it? That'll get rid of that 78. And the X will be alone. So X will equal, then just hit the buttons on your calculator. Just take 13 times 390 divided by 78. Let me know what the answer is. 65? 65. The other number must be 65. So it's kind of interesting. If you know the GCD and LCM are two numbers, and you know one of the numbers, you can find the other. It's kind of a surprising little truth. All right, we better move on. Okay, so let me let you write that down. GCD by the Euclidean Algorithm. 323 and 2419. Okay, so how do we do the Euclidean algorithm? Basically, what we're going to do is, it's a really weird thing. What would be the best way? How about I do it once, you just kind of write it down, then I'll write some words for what I did, and then I'll do it again more slowly. It's going to be one of those weird kind of things. You're going to be like, whoa, what did he do? It's a weird little process. So I'm going to do it twice. I'll do it once, write out what I just did, and then do it again. I think it'll sink in the best way that way. Basically, Euclidean algorithm means divide, means long divide. It's a fancy thing to generally mean long divide. So I'm going to take 323, and I'm going to long divide into 2419. That's what I'm going to do. I'm going to find the GCD this special way by long divide. Now, I'm not going to do it all by hand. Grab your calculator, right? You don't want to do it all. We've got a calculator. Just take your calculator, take 2419, and divide by 323. Please tell me what the answer is there. Yeah, go ahead. Is it 800 something or 700 something? 7 something? Yeah, 7 something, isn't it? 7 point blah, 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 right? Am I right on that? Okay, we don't care about the blah, blah, blah. All we care about is the whole number. So then you go up here and you put the whole number. We're not going to do decimals. So we just throw away the decimal, And just say, okay, and we're not rounding. We're not rounding. Even if it was 7.9, I would just take the 7. I'll write all this out in a minute. You just take the whole number, the 7, and that's going to get you started on your long division. Now, take 7 with your calculator again, and take 7 times 323. What is that? 2,261. Thank you. Then subtract. Right, we're just doing normal long division. You go ahead and use your calculator. Subtract those. What's that? 8, 4, put 3, put 1, 5, 158. All right? Are we good so far? I just did one step of long division, right? Everybody good? So I'm going to do something weird now. This is where it's going to get weird. So that was just long division with the calculator. I'm going to grab this number, the remainder. This is the remainder, right? And I'm going to grab this number, and I'm going to rotate them. This is going to go this way, and this guy is going to go in there. So I said it's going to look weird. I'll write it out in a minute. So 158 will end up on the outside. Let me give a little more room down here. 158 will end up on the outside, and the 323 will end up on the inside. You rotate them. The remainder goes to the outside. And what was on the outside goes in. It's like turning a clock. See, it's a clockwise rotation. They rotate. Now, I know this is like magic. I haven't given any reasons. I just don't have all that much time to give reasons right now. Maybe later if time allows. So, all right. So now, do the same thing. Long divide again. So take your calculator over here and go 323 divided by 158. It's going twice. I think twice, right? 2 point whatever, blah, blah, blah. So then put a 2 up there, and then use your, what is 2? I don't care about the decimal. 2 times 158 was at 316? Yes. So 316 subtract 47. Do it again. Rotate. You keep doing this until you get it to go in evenly. And then our answer will be, I'll show you where. So now we rotate again. Grab this, everybody rotates. He goes here, he goes in. So next step's going to be 7 on the outside, 158 on the inside. You just keep doing this. The remainder rotates. And then use your calculator. What's 158 divided by 7? What is it, 20 what? 22 point whatever. So put 22 up here. And then 154? Yeah. 154 subtract 4. Do it again. Rotate. Just keep rotating. We're almost there. Rotate it again. So the 4, the 7, 7's going in, 4's going back there. I'm going to erase some of this stuff on the side here. And we've got 4 into 7. Now we can do it by hand. 1 time, remainder 3. Do it again. 3 comes up here, 4 goes in there. So we've got 3 into 4, goes in 1 time, remainder 1. Can't believe it. They don't normally go this long. Rotate it again. This goes here, this goes in. This is going to be the end of it right here. So last step, 1 goes into 3. See what happened there? The 1 came up here, the 3 went in there. 1 goes into 3 3 times, no remainder. You're done. Where's my answer? Well, I think it's here. Let me double check. I guess it's out here. It's out here. It's not in the top. Ignore the number in the top. It's like the Wizard of Oz. Ignore that guy behind the curtain. It's the number in the side. This is your answer. So in other words, those two numbers have nothing in common, is what that means. That was a weird one. These two numbers have nothing in common. Let's do another one. That was a totally weird one. Oh, the other one was answer 1, 2. I saw it on the answer key, huh? That's weird. I don't know why they did that. I don't know where I got those questions. Let me make up one that's not that way. Let's try one. How are we doing on time? Okay. Let's try one. How about one we did earlier? Yeah, let's do that. What's one we did earlier where we got a GCD? One of the really painful ones. How about one of them? Yeah, one of these. 8, right? The GCD. Well, that was for 3 numbers, huh? Oh yeah, those I just did them for 3. I don't have a 2 number. All right, let me just make one up. What is the GCD for 20? and 64. What do you think it is? What's the biggest number you know that goes evenly into both those numbers? Can you tell just by looking? What goes into 20 and 64 evenly? 2 does, but what's the bigger thing? 4. 4 is the biggest number. Yeah, 4 is the biggest number that goes in. Anyway, let's do the Euclidean method. So what would you do with the Euclidean method? So I'll do it by the Euclidean, which means the long division thing. So you go 20 into 64, and you long divide. You just calculate if you need to. What does that go in there? 3 times? So let me let you do the first step rather than me just rushing ahead. Go ahead and do that first step. Give you a second on that. So it goes in there 3 times, right? 3 times. And 3 times 20 is 60. Subtract 4. And then what do? You rotate. I might be running out of time to write this down, so you might have to just go with the steps I've shown. So you rotate like that. So 4 goes up, 20 goes in. And we do another step. How many times 4 go in there? 5 times. That's 20. As soon as you get 0 remainder, where's your answer? Yeah, not at the top like I thought. It's right there, which we already knew. That was the biggest number. See, it works, doesn't it? Am I good? So let's spend 3 minutes on the true-false question. Euclidean thing. If you just go until your remainder is 0, and as soon as your remainder is 0, the answer is there when the remainder is 0. You just go until you get a 0 remainder, and then your answer is on the outside. Is that. So the answer is on the outside when the remainder is 0. Okay, let's do a true-false, and we'll call it a day in the end of this homework section. So, okay. So on this one, they're going to have 4 true-false questions. I will have these on the exam. You'll see them on the practice exam. So what are they asking me in Part A? Let me just grab Part A. It's about all we're going to have time for. So Part A is saying the LCM of A and B, straight line, GCD of A and B. Now, what is that straight? Then they're asking me, is that true or is that false? What does that straight line thing mean, first off? Divide. Long divide. Notice, if it helps you, you can just make it long divide like that. That's what it means. They're saying the number on the left goes into the number on the right. That's what they're saying when they put that straight line thing. So, and they're saying, is that always true for all numbers A and B? See up there it says where A and B are any numbers. Well, I don't know. How do you know if they don't even give me numbers? Exactly. You know what you do on these? Just pick numbers at random, see if it's true. Now, just because it's true for some numbers doesn't mean it's true for all, but that'll give you a good feel to start with. So I would just say, I don't know. I have no idea. Let me just pick how about 2 and 6? A is 2, B is 6. Whatever A is, it's the same number in both cases, so is B. So let's see if it's true. What would be the LCM for 2 and 6? Yeah, if you, there's not a lot of time here. But yeah, if common denominator, that's what it is. If you were adding fractions, 2 and 6 were doing, 6 would be the common denominator, right? That's what LCM is. You could use any of the formal methods, but I'm running out of time, so I'll just say, well, the LCM would be 6 for 2 and 6. And what would the GCD be? What's a tiny number that goes into 2 and 6? 2. So does 6 go into 2? No way. It's backwards. 2 goes into 6, not 6 into 2. So that is false. Uh-oh, they have 3 false answers. I'm not going to do that on the test. There'll be no words. It'll be true or false. I don't know which one is right here. The LCM of 2 numbers. I don't know. I'm going to say false. I'll let you read all the words. The answers are there. So that's the best we could do with our time. I'll stop.